So we stopped here where we wanted to create a cluster, and I didn't have any clusters in my the workspace because it's a new one, and I wanted to create this to you here so you have the process of creating your own compute cluster, as we did with the databases, with the data set, sorry. So you create a new cluster in the virtual machine, dedicated one, it's a CPU, and we go select from all options and we choose this one, the 2-core for 14 gigabyte RAM, 100 gigabyte for storage. We say next. And in here, you can call your cluster anything really. I'm just going to call it a cluster. I'm going to give it a name. I'm going to say auto ML cluster, so I know which one I've used it for. I'm going to use 2 numbers of nodes, and I'm going to use 120 seconds for scale it down. I'm going to keep this unselected, and all of these configurations, I got them from, they are default one, I've got them from the Learn Microsoft material, but I would say you can experiment with different options. I'm going to create my cluster now. So that will take a couple of minutes for the cluster to be created. So now we wait a couple of minutes. Obviously, I paused my recording for the cluster to be created, and that is done. Now I click Next to select the task. And the type of the task we want to select is regression. The module will predict a numeric value. So that's what we want. And then look at additional configurations. The primary metric, we will select the normalized root mean square, which is by default selected. Explain best model. For that, this option causes a automated machine learning to calculate the feature importance of the best model, making, obviously, it will make it possible to determine the inference of each feature of the predicted model. So a list of algorithms that automated ML will not be used training. And then we've got exit citation. That's we training job time. We change that to 0.25. This causes the experiment to end after the maximum of 15 minutes. The metric score threshold, we will choose 0.08. We'll choose this value. This will cause the experiment to end if the model achieves the normalized root mean squared error matrix score of 0.08 or less, which is quite good. What else we do have? The validation, the concurrency. I think that's it. A block algorithm, we don't need that. Here, we're going to block everything other than 2 algorithms. Random forest, we don't want that. We don't want that too. And we're fine. Yes, that's it. And then now we finish and creating our module, which will typically take a couple of minutes, which has not done. We've got it here created and ready. Just a few things we need to check. We've got right, auto, and that's fine. Cool. Now our module is running. Our status is changing. still setting up the run. We'll wait for a couple of minutes and we'll come back and see our results. And now after we have the completed status, then you can do so many things to view the results. You can look at the modules. Obviously, we got one here because we don't want it to take a lot of time, sampling 100%. You can look at the matrices, the evaluation matrices, the mean square, the mean absolute error, the median, and so on and so forth. This is it for today. This is a complete no coding machine learning module. We haven't used a notebook where we can do Python. We didn't use Python. Everything was built in. There's other things that you can create as well, apart from creating automated ML. And we've learned through the automated ML, creating an automated ML is basically we learned how to create some assets, one of which is data sets. Other things that you can create is modules, pipelines, and pipelines will help you deal with your data, prepare it, and pre-process it very well. You would have a couple of labs doing this. I might have to record one quick one to explain how you go about the pipelines quickly. But basically, this is very important to know that you have authors, basically the notebook, which is your Python code, automated ML, which is a zero code, machine learning, supervised learning, modules, designer, which will help you design your supervised or unsupervised learning modules, assets, where you can create some assets to help you with manage your modules, and then computes, data sets, management, basically tools, computes, which is your computers, virtual machines, data stores, and so on and so forth. I hope you find this helpful, and I'll be recording a couple of more videos to set you on the path, hopefully successful path to get your certificate. Thank you for listening and see you. Take care. Bye.